Today we're going to work on logarithm functions. Our learning targets are to express a log equation as an exponential equation, express an exponential function as a log function, evaluate logarithms without a calculator, use the definition of logarithms to find a missing value, use a calculator to evaluate a log expression and round the answer, and then graph a log function. Okay, so you already know that 2 to the second is equal to 4, and you know that 2 to the third there equals 8. However, if you kind of think about this, what in the world is x when you take 2 to what power is given to give you 6? Well, we know it's somewhere between 2 and 3, but we're not sure. Well, what happens if someone asked you to go out 3 decimal places? Would you know what that is? You'd have to guess and check and keep checking and guessing and all that stuff. So we came up with logarithms in order to help us to find that power, and we don't have to do so much checking and checking and checking and guessing and doing all that stuff. So that's the purpose of logarithms. So this is the big definition that we're going to be working with over and over again. So basically, if you have b to x there equals y, then log base b of y is equal to x. And we can go backwards and forwards with that. Log base b of y equals x, and b to the x equals y. Those same values go into one or the other equation there. So in other words, over here, we have log base 2 of 8 there equals 3. Well, that is 2 to the third equals 8. You take the subscript of 2, take it to the third power, what's over on the right of the equals, and it's equal to 8. And so then log base 5 of 25 equals 2. That is 5, the base, to the second power is equal to 25. We're going to be using that definition over and over and over again. So here we have what's called a common logarithm. So looking down here, right down here, it says log base 10 of x equals log of x. We don't write the log base 10, and on your calculator it just says log. It means log 10 because that's the most common logarithm we have. So that's equivalent, log base 10 of x is equivalent to log x. And then over here we have this natural logarithm. On your calculator you don't have log base e, you have the ln of x. That's the natural log of x. And so that's the same thing as log base e of x. Those are the two special ones. So let's go ahead and let's work with, if we've got a log, can we write the equivalent exponential? So using the definition of logarithms here, we can take 6 to the second is equal to 36. The base to the power equals 36. Letter B there, the natural log of 12 is the same thing as log base e of 12. And so we can rewrite that. It becomes e to the x equals 12. Our base is e, the power is x, it's equal to 12. All right, so likewise for letter C there, if I rewrite that as equivalent logarithm there, natural log is log base e of 2x plus 1. The equivalent exponential there is e to the third equals 2x plus 1. Now we're not trying to solve this for x, we're just writing the equivalent exponential. All right, so then down here, the equivalent exponential, 5 to the third equals 125. And then the next one here, log base e of 25 equals x. So what does that mean? It means e to the x equals 25. Example 2. Now we're going to go the other way. So keep in mind here, let me go back here. I'm going to go back to the definition here. So over here we had b, the x equals y. I want to keep it going with the same letters. So if I write that down, b, the x equals y, the equivalent logarithm there is log base b of y equals x. So over here, 7 to the second equals 49. The log base, that's subscript down there, of 49 is equal to 2. Follows this over here. Log base b of y equals x becomes b to the x equals y. Or b to the x equals y becomes log base b of y equals x. So that's why it's log base 7 of 49 equals 2. Same thing here. So log base e of 5 equals x. But then we're going to change that because that log base e there is the same thing as a natural log. So we're going to have natural log of 5 equals x. Letter C, log base 2 of 1 over 16 equals negative 4. Letter D, log base 3 of 81 equals 4. Letter E, log base 5 of 1 over 125 equals negative 3. Again, using this formula over here, that definition of logs, b the x equals y is equivalent to log base b of y equals x. So that is what we've been working with, that formula over and over again. So similarly, we're going to do something similar over here. I'm going to set these equal to x. So let's try them out. So now we have 3 to the x equals 1. So now you can think, 3 to what power there gives you 1? Oh yeah, 3 to the 0. Anything to the 0 power is 1, so 3 to the 0 of course is 1. Next one, I can do the base to its power is equal to 7 to the 10th. Since the bases here are the same, you've got a 7 here and a 7 here, then the powers must be equal to each other, so x there simply ends up being 10. Likewise down here, the base down here, we don't have it there yet, so let's write it. Natural log is log base e of e to the 4th equals x. So what does that mean in terms of equivalent exponential? It'd be e to the x equals e to the 4th. So now the bases are the same, so that means the powers have to be the same. All right, and then letter D here, same thing. We got 9 to the x equals 81. So 9 to the 0 is 1, 9 to the first is 9, 9 to the second, oh that's 81, so x has to be 2. So again, we're looking for you to see that x is 0, x is 10, x is 4, and x is 2. Again, using the definition of logs. So let's write this. 2 to the x equals 16. So if you don't know, you can go on your calculator. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth, oh yeah, that's 16. So x is 4. Let's do the next one. 4 to the third is equal to x. That's the equivalent exponential. What is 4 to the third? Well, 4 times 4 is 16, and 16 times 4 is 64. Or you can just put in your calculator, 4 caret key 3 gives me 64. Natural log, remember natural log is log base e. So that becomes e to the second equals x. We don't actually have to find e to the second, we just can say e to the second equals x, unless it's had to round out. All right, letter D. This becomes 3 to the x equals 81. 3 to what power is 81? So again, if you don't know, use your calculator, let it help you. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth. Oh yeah, that's 81. So x there has to be 4. Because 3 to what power is 81? It's 4. All right, and letter E here, it's 5 to the second equals x. What is 5 to the second? Oh yeah, that is 25. So x there is 25. So now we're going to evaluate the log expression using a calculator. So if you've got the 84s, most 84s will be able to calculate it, and it will look like this. If you have some other calculator, it may or may not have this button that we're going to use. So first of all, I'm going to do this for those of you who have the 84s. And so what you want to do is you want to go underneath the math key, check to see if it's there. I'm going to use the up arrow to go backwards because the list is really long. And I'm going to go up to log base, and I'm going to hit enter. Now if yours doesn't have one, don't panic, I'll show you how to do this shortly. So log of base 5, use the right arrow, go over inside the parentheses, hit 55, I'm going to hit a right arrow, and then I'm going to hit enter. It's going to tell me it's 2.489896102. We're supposed to go up 4 decimal places. So 489, it's an 8, but that 9 is going to round that 9 up. So it's 2.4899. Did not forget those of you who don't have this calculator. All right. If you do not have log base on your calculator, this is what you're going to have to do. You're going to have to punch in, there's a log button on all your calculators. So you can do log, you're going to put in 55, you're going to do an end parenthesis, and you're going to divide it by the log of that little subscript. So the log, in our case, of 5. And I'm going to hit enter. And I'm going to get the same answer, 2.4899. All right, so now let's do both of them the same here. Let's do math key. I'm going to use the up arrow. I'm going to go to log base. I'm going to, in the 3, I'm going to put a 3. Inside the parentheses, I'm going to put a 10. I'm going to hit enter. And it's going to tell me 2.09590. 2.0959. Those of you who don't have an 84, your 84 doesn't have one of those, not everyone has it. You'd have to do log of 10, end parenthesis, divided by log 3. And you are going to get the same answer, 2.0959. All right. You also, everybody has a natural log button on their calculator. So now hit natural log of 40. Hit enter. It's going to tell us 3.6888, and then there's a 79. So that 9 is going to round that 7 up to an 8. So 3.688. 1, 2, 3, 4. We're on the 8 up to a 9. So 3.6889. Right? And then we have one more back down here at the bottom. Log base 2 of 110. So I'm going to go underneath my math key. If you are doing it a different way, then you use yours. I'm going to do it this way, what my calculator allows me to do. 6.7814. 5 or larger in the 5th place is going to move the 4th place rounded up. So 6.7814. All right, so now we're on to graphing. The easiest way to do this is to use your graphing calculator. So you can go to your y equals here. I'm going to go ahead and plug in log base 2 of x. So I'm going to go up, go to log base. I'm going to plug in log base 2 of x. I'm going to hit graph. There's the graph and you can see it. That's what yours should look like. So now you're going to go to the table, get some table of values. So if you look up here, you see how the calculator is erroring up there. You're not going to go and we're not going to graph those ordered pairs out. So let's do what we're supposed to do right here and graph those out. So I'm going to do a little t-table here. It told me there are some values, so I'm going to take those. 0 is 0, so I'm not going to do anything with that. 1, 0, and 2, 1. Oops. 1, 0, 2, 1. And there was one other one there I wanted. The next nice one there, where I don't have a long decimal there, is 4, 2. So let's plot that. So now what happens here is that it goes down towards the y-axis. It does not cross the y-axis. And then it goes off in that direction. Okay, it doesn't cross the y-axis, but it's got to go along there. Unlike the radicals, remember the square roots, it started there at this dot right here, and then it just went off to the right there. This one here backs up and comes back down toward the y-axis, so make sure you do that. And so then we have to name the domain and range. If you notice the domain left to right, well, it stops here. It doesn't go beyond that y-axis there. So that's a parenthesis 0, and then it goes forever to the right there, so that's infinity. And then the range there, it's bottom to the top, well, it goes to the bottom forever, so that's negative infinity, and it goes to the top forever, so that's infinity. If you remember, logs and exponentials are inverses of each other. You probably learned that last year in Algebra 2. And so their domain and range here are swapped. For the exponentials, it was, for domain, it was negative parentheses, negative infinity, comma infinity, parentheses. And for the range, it was parentheses, 0, comma infinity, parentheses. They're swapped. So now let's do this one, natural log of x plus 1. So I'm going to go to my y equals, clear this out of here. I'm going to do natural log of x, end parenthesis. Make sure you put that in parenthesis, plus 1. Hit graph. There it is. I'm going to go to my table, so second table. I'm going to get my little nice table here going. I'm going to look at my 1, 1, and it doesn't look like there's anything nice after that, so I'm going to have to sort of write some other one of those rounded one answers down. Let's look at some of the rounded answers there. So maybe like 3 and 2.1. No, I'll probably just jump up there and look at something farther up there. So maybe like I don't know, 8 and 3.1. So 1, 1, 3, 1, 2, 3, and 2, and then a little bit up above that. And then at 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 3.1, so a little bit above 3. So now I'm going to connect them. Remember, it doesn't change here. It kind of goes along the y-axis. Sorry, I'm not connecting that very well. Doesn't cross over the y-axis, so don't do that. I think I might have crossed over there. Here, let me connect that better. There. So now you can see definitely coming along by that y-axis. So my domain here, left to right, it doesn't go beyond 0 there, so 0, and it goes to the right forever, infinity. The range bottom to top, it goes to the bottom forever, that's negative infinity. Yeah, sorry. I'll just erase all that and start all over. So domain there. We said 0, comma infinity, range, bottom to top, so that's negative infinity, top infinity because it goes forever up. So you are going to be working on that 5-3 worksheet.